Hello everyone, my name is Ursula Ron. I'm Marketing Director at Morphisec. Welcome to today's webinar, Meltdown and Spectre, where the real risks lie. And thank you for joining. Some of you are familiar with our webinars, and you know that usually we present a deep dive into cybersecurity issues. So this webinar is a bit different. It is planned as a 20-minute live Q&A session. We actually already received questions from customer and prospects, but you are cordially invited to send in your questions during the webinar. We also would like to use this platform to add insights we believe missing in the current discussion about the CPU flaws. It is my great pleasure to welcome Michael Gorelik, CTO and Vice President of R&D here at Morphisec. Michael is the one we turn to whenever we try to understand the impact of an attack or threat. He is a real cybersecurity expert, but not less important, an educator who is always willing to share his knowledge. So let's just start with the questions. So, Meltdown and Spectre. Michael, could you give us the background, what these vulnerabilities are?
Right. Yeah, great. So, as you start this webinar, I will try to describe in really 2-3 sentences what it's about. So basically, some of the optimizations, some of those CPU vendors implemented, Intel, ARM, AMD, etc., are branch prediction and speculative execution. This is done for performance reasons, and basically, what happens is that when you have a specific program that runs, the CPU will try and execute the next command. If at the worst case scenario, it happened not to be true. For example, if you have a branch and the CPU predicts that the next command will happen, it will execute few of the first bits. But if this branch failed, then the CPU will roll back. The problem with this is that the next command and information is kept in the cache and in the history of branches. This is done there also for performance reasons, so that the next time the program will do the same, it will know how to predict well the next execution. And this is how you get better performance and not waiting for a decision of a branch. This is also misused by the attackers. They basically can use the speculation execution and cause the branch to fail while the CPU thinks the next command will execute, and therefore to push the interesting data into the cache line and read it with different methods. This is more or less in general lines, the vulnerability.
Thank you, Michael. How would you describe the impact of these vulnerabilities on the IT world at large, but also on each personal user or the Seesaw that needs to secure his enterprise?
Right. So this is a very good question. Basically, we need to look on this vulnerability from two sides, two views. One is someone that wants to steal information, to map your memory, to steal whether it's passwords, credentials, credit cards from the memory. And the other one is, from my point of view, much more critical aspect is the use of part of an exploit chain. I will explain it a bit more. So if you use this vulnerability only to dump or read memory, this is a one-time thing. You read the memory, that's it. If an attacker, and usually the attackers would like to run malicious code on the computer to do advanced stuff, for example, literal movement inside the network, to install keyloggers, to track the user and do active things. This is not possible by only reading memory once. So eventual goal of most of the attackers will be to run a malicious code on the computer. Today you have two ways. One is just put the executable, but the complicated way is doing it through exploitation without the user consent. If we look and focus for a second on the web exploitation, for example, and see what are the conditions for a successful exploit to happen, and those are two conditions. One is to read memory, to read process structures that could be used to bypass known mitigation for today, like ASLR and DEP. And in other words, you will see technical words are also called read primitive, as well as info leak. And the other condition is write primitive or code execution, which means you do have all the information inside the memory you need. Now you can perform the return-oriented programming or your shell code based on this information. You can redirect the flow by changing and writing to memory. So read to memory is an important aspect. You need also write to memory. The problem is that in last couple of years, 1 or 2 years, um, there have been a lot of mitigations. The regular ways like type confusion and user for free and all those methods are a bit less relevant and very not easy to implement. But now using this um, read primitive, this information leakage that is already exists as a POC in JavaScript, you don't need type confusion or use after free. You can read the memory structures from the memory, and you just need write primitive to redirect the flow to your code. So basically, we will see much more exploits as soon as it will be used by the adversary. Yeah.
Uh, how did I dare to say that this will be no deep dive when I have you on a webinar, Michael? Thank you ever so much for the details. Many people out there are asking what they can do to protect themselves. There is a lot of confusion about patches, what has been pushed out and what not. Could you clear up this situation for us a little bit?
Right. Right. So actually, those updates that are exist and have been are pushed by the OS is because the vendors, the CPU vendors, have tough time to push their firmware updates. So basically Windows and others um, created updates by minimizing those technologies, performance technologies that allow you the performance boost you are used to in the last couple of years. So by updating this those updates, you will your computer will be slower. There will be less impact of branch prediction, etc. And also the other aspect is that some of the security solutions, I will not name names, they're really very seriously use kernel information, kernel data, including those cache lines, and some of them are not compatible today with this update. This is why Microsoft decided for those not compatible AV solutions, said we are not pushing the update by ourselves. The AV is responsible to put a registry flag inside the registry, and this way we will know the AV is ready and now supports this update, and then we will push this update. Um, there are many AVs which are compatible, some which are not compatible. It's easy to check. Just go into registry according to our, we sent in our mail delivery what registry you should look for. You can validate that it exists. You can also check if you are updated. You need to check those two. We also have instruction to both of them. But if the registry do not exist, you need to approach your AV vendor and check with him when will he add this registry, when will he have updates that will support this Microsoft update eventually.
So just in this context, I want to say that Morphisec does not collide with the Microsoft security update. So no problems here. Which brings me to the next question. What benefits can our customer gain of having Morphisec in their security stack? How does Morphisec cope with Meltdown and Spectre?
Right. The biggest advantages, as far as I see, is in the exploitation aspect. I already covered it. As I predict, it's actually easily you can prove it with the existing POCs you have today, that there will be more exploits, and this will be part of the very useful methods to use an exploit that previously didn't have read primitive conditions. Morphisec leaves traps, memory traps in memory, and we are morphing the original memory. So basically, the attacker will read the memory, but gets into the wrong resources, and therefore will execute whatever we want them to execute, and Morphisec will prevent it immediately. So basically, those type of exploits, exactly as today, you have a lot of exploits that bypass ASLR by sophisticated techniques, will be prevented the same way by Morphisec as before. If we are now getting out of this aspect of, for a second, exploitation and talk only about this one-time memory snapshot, in this case, although it's out of scope for Morphisec, we are preventing code, which is code executed. And in case of memory scrapping, you already need code that is executed on the system. So basically, either if it's very advanced code, we should also prevent it. If not, then your AV should prevent it. And we also do additional side morphing, which a bit complicated the use of a cache to extract specific data, so the attacker will have a bit more difficulty to get his information from the memory.
Michael, I'm taking a step back, looking at the entire picture, and just as we recently discussed in a webinar, the entire attack vector of in-memory attacks is growing enormously. So even here we are talking about a firmware attack, and we are landing up in the memory.
Yeah. So the question is, what do we see with regard to attack vectors? So basically, this vulnerabilities like Meltdown and Spectre are a result of a long research of side channel attacks. Basically, the basic research that is that the start of this vulnerabilities already exists about a year or two ago, and the CPU vendors didn't treat it as they should. I do suspect that there will be more side channel attacks on hardware, and basically the attack vector of exploitation will be much bigger. It's not that it's not big. All the memory attacks are already, I would say, above 70%. It will be even bigger because this way you have less trace. So I do suspect an increase in attack vector together with side channel attacks and exploitation, of course. Yeah. I do see also maybe some of those post scrappers, point of sale scrappers, will also adopt some of those techniques, maybe, because these vulnerabilities are actually across CPUs, across vendors. So yeah, we have also one more question here about maybe Ursula, you can read it.
So this is a question from Alexis. It seems to me that Microsoft Apple Linux updates are just protecting against Meltdown, except for Internet Explorer and Edge. Could you confirm that Spectre has to be patched by each application editor? And if it is like this, is Morphisec a sure way to protect computers against Spectre exploitation codes?
So, well, it's a good question. Everyone is vulnerable. Microsoft, Apple, Linux, the phones as well. And the current patches are actually some kind of temporary. Eventually, most of the vendors like Intel are promising to push. They already pushed some updates for the firmware, and they have some SLA to some thoughts about they saying that the performance will not change too much after their update. So I assume there will be updates soon from the firmware. As regard to exploitation that are using Spectre for info leakage as part of the attack chain, yes, Morphisec will protect those on the Windows computer. We currently support Windows. Um, and yes, this need to be patched by vendors. But for now, Microsoft Linux have their OS patches, and you should update, of course. The difference between Heartbleed, which is also InfoLeak, is that the Heartbleed disclosure was very limited, and updates existed immediately. It wasn't actually used a lot by the attackers. But in this case, we have much wider impact. Um, some updates for Spectre still do not exist, so it takes time. Uh, there is one more question. What will be the impact post applying the patch? Is there any CPU performance degrade? Yes, there will be CPU performance degrade, and it will be most how it's called. And the biggest impact will probably be on those sensitive environments, cloud environments, those that share resources. You will have impact there. Yeah. Some say impact of 30%. So this is why actually Intel and others are doing first the push of their firmware to those vendors.
Okay. So
Okay. I do have one more question here. Yeah. In my mind, you are morphing process memory and not kernel memory, so how could you detect the attacker tried to get kernel memory using Meltdown flow? That's a great question. We choose not to go to kernel, not to disturb the operation, cause the blue screens. The memory could be read. Even with Morphisec, you can read memory if you need to read the kernel memory. The question is whether you do have a code execution. So if you already have malicious code running on the system, then yes, you can read kernel memory. We are not morphing it. But if you do not have code execution there and you want to execute code, in this case, reading kernel memory will not help you. You're still not executing in the code, so you'll need first to bypass all those mechanisms of ASLR, the sandbox of, for example, a browser. So you need to run your shellcode outside the sandbox, and you need to do all those regular operation of any exploit. The fact that this vulnerability helps you to find much easier exploits is a fact, but you still need to exfiltrate this data. Yes, there will be cases like Heartbleed in which you can exfiltrate some data from kernel or user mode. The eventual goal of an attacker will be usually to persist or to literally move into the network. So just a snapshot of kernel will hardly help him. Maybe for banks it will be more sensitive, but in this case, they usually have isolated network. So I'm less sensitive to this case. What will be additional question? What will be the way to avoid this attack? So basically, because this is eventually a code execution, yeah. So you would, of course, want to put the original stack, we're always presenting the stack. You need the stack of AV, you need the stack of advanced threat, which is MorphoSec, etc., to prevent the malicious code execution. You need anti-exploitation solution, which is also MorphoSec. It's not like or any other solution that you prefer, but eventually you need to block the exploitation as well. If you certainly need to patch, but there will probably be more side channel attacks. You need to isolate networks. It's all dependent on the environment. It's a webinar by itself. What you should do. It's very dependent on the type of customer, type of environment, whether your network is isolated or not. So there are a lot of additional questions we can answer on different cases.
Thank you, Michael. I think it's the time to wrap up. I hope we answered the most urgent questions. We certainly will have an eye on the developments around Meltdown in Spectre. We might have a follow-up webinar in a couple of weeks. There are still some questions coming in, so we certainly will answer them by email. Michael, I would like to thank you. Thanks to the audience. A reminder, there is good information on our blog with tips how to deal with Meltdown in Spectre. And we are left with wishing everyone a happy, successful, and safe 2018. See you soon on the next webinar.
Goodbye.